Hello students, in lesson number 10, light reflection and refraction, let us move further. In the previous lecture, we have learned about the spherical mirrors and the types of it. Okay, so now we are going to learn about the image formation by spherical mirrors, concave mirror and convex mirror. But it means how these mirrors are giving the image, what kind of mirror, what kind of image is formed by these mirrors. Okay, as we have seen in plane mirror, the image is virtual, erect, of the same size of the object. Okay, but in this spherical mirrors, what will be the nature of the image? What will be the size of the image? Okay, what will be the distance, at which distance the image will be formed? Okay, so all this different cases we will take for both the mirrors, concave mirror and convex mirror. So in the image formation, as you have remembered that we need two rays for the image for the location of the image, right? The two rays originate from the object. That two rays meet at some point, right? So at that point, the image of the object will be formed. Okay, so any two rays can locate the image. So, but for the spherical mirrors, which two rays we need to take? Okay, so there are some of the very specific rays we can take to locate the position of the image. Okay, so which specific rays we can take? Here are few rays, very specific rays we can say. That rays will be will give us the easy way to locate the image of the object. For the spherical mirrors, we are taking both the mirrors together, concave mirror and convex mirror. Okay, image formation by the spherical mirrors using ray diagrams. Okay, we have used here. We are representing the light rays as a ray. Okay, and so this kind of diagrams is known as ray diagrams. Okay. So let us take one by one. First one. If a ray of light is parallel to principal, okay, this is a concave mirror. It has P pole, F focal point, and C center of curvature on a principal axis. Now, if any ray is parallel to the principal axis, then after reflection it always passes through focal point F. Okay, we have to remember these things. Okay, a ray parallel to principal axis, after refraction it passes through F. Why it passes through F? Understand here, whenever we know the rule of we know the laws of reflections. Okay, and the first law is incident angle is always equal to refraction angle. Okay, so if at this curved surface, if we draw the normal, we can draw the normal of this curved surface. It will be like this. Yes. So this incident angle makes some angle with the normal. Okay, so incident ray making angle with the normal, that we are calling it I, and so the reflected ray will reflect in such a way, will go in direction in such a way that it makes the same angle I with the normal. Okay, so at each point, the normal will be at different angles. The normal will be different. So at each point, following the incident angle equals to reflection angle, all the rays parallel to principal axis will reflect in such a way that it passes through focal point F. Okay, so we are not worrying about it. Always follow the rules of reflections. So we are not going to worry about it. Just we need to remember that a ray parallel to principal axis passes through F. Now, for the concave mirror, for the convex mirror, it will be reflecting outward and shaded inward. So if any ray parallel to principal axis will be reflected in this direction. Okay, because it is curved outward. Due to, but we can, if we extend this ray, we can simply see that it is coming from point F. Okay, so parallel ray appears to be coming from F. Secondly, if the incident ray is passing through F, okay, if the incident ray is passing through focal point F, then after reflection it will become parallel. So these two cases are the inverse of each other. Okay, if the ray is parallel, it passes through F, and if it passes through F, it becomes parallel after reflection. For the convex mirror, if the ray is coming, it looks like it passing through F. Okay, so this incident ray is coming in this direction. After reflection, it becomes parallel. Why? Because it is looking like coming from F. Third ray. If any ray is passing through center of curvature. Now understand here, it is center of the sphere from which our mirror is a part. So if it passes through the center, it means this makes a radius, and we know that radius is perpendicular to the surface, right? It means that a ray passing through C actually incidentally normally on the mirror at any point, because radius is always perpendicular to this tangent. Okay, at that point. So at that point, radius will be perpendicular every time, at any point on the circle. So the ray passing through point C, incidenting normally. So if any ray incidenting normally to the surface, it comes in the same direction. So it reflects in the same direction. Okay, reflect back. Same way, if a ray coming to the mirror, it looks like it passed through C, then it will be perpendicular. It will be normal to the surface, so it will reflect back in the same direction if it is passing through C or appears to pass through C. Now fourth one, if any ray incident at some angle, which is also called incidenting obliquely, okay, making some angle with the norm, okay, principal axis. Principal axis is passing through C, so it will always be normal. So, at normal, if it is making angle I, incident angle, making some angle, then it will reflect in such a way that it makes the same angle reflection angle. Okay. So, if any incident angle pass through C, passing incident on the mirror, making some angle, then it will reflect, making the same angle. Same way for the convex mirror, again ray of light incident on the mirror, making some angle, it will reflect, making the same angle. Okay. So these are the very specific rays we can use to locate the image of the object. So, by using the specific rays, we can locate the position of the image. Okay. So now we are taking the image formation by concave mirror, and then we will learn the image formation by convex mirror. Different than the plane mirror, whenever the object is placed in front of the mirror, okay, this image depends on the position of the object. Okay, it means if the position changes, then the nature of the image changes. Okay, so we will take a different case. We are putting the object at different positions in front of the mirror, and we will see that what kind of image we are getting. Okay, so first case we are taking. Okay, there are total 6 cases. One by one we will take. Okay, so first one. For that you need to draw the mirror, concave mirror. Understand here, you draw the concave mirror using the rounded, okay, with some radius. Draw a concave mirror such that it makes a small aperture, okay. For a bigger aperture, we are not this image formation will be different for the bigger aperture. So we are taking the mirror with small apertures. Now draw a mirror with the diagram. Don't make very curvy like this. This kind of curvature will not give the exact image formation, okay. Draw the curve. Draw the mirror with a bigger radius, okay. Set your radius for the rounder bigger, okay, so that it makes a flat curve. Okay, that kind of mirror will give the exact image formation, okay. So now draw the mirror with rounder, and then the center, whatever center you have put, the point of the rounder will be the center of curvature. Okay, set the C at whatever point you have taken this, because that circle will have C center. The center of the point rounder will be the center of curvature. Okay, so point as C. Okay, and then F you will locate the half of this radius will be the F. So F you will locate it. Okay, so if you are not very specific with this distance, you are not getting the exact image formation. Okay, so just remember this. The point of your rounder will be the C, and you locate half the distance you locate F at half the distance. Okay, that will give the exact image formation. Okay, so draw the concave mirror. Shaded one part, outward it is shaded. Principal axis, center will be P, then your point of the rounder will be C, and half the point will be F. Okay. Now, first one, we are taking the object at far distance. Okay. So if the object is at far distance, then the rays coming from that object will be parallel. Okay. Because the object is at very far distance. So that rays will be that rays coming from the far distance will be parallel. Okay, all the rays will be parallel. So that rays will come parallel to the mirror because the object is at very far. Okay, so the rays will be parallel. So, and if the rays are parallel to the principal axis, from where they are reflecting? They are reflecting in such a way that they all pass through point F. Okay, all the rays are parallel coming from this far object. So the rays are coming from the far object are parallel. So all the parallel rays passing through. So all the rays will meet point F. Yeah. So we can see that, and wherever the rays meet, that at that point the image is formed. So the image is formed at point F. Understood? So what can we say about the image? So some result we need to write. What should we need to write? Position of the object. Okay, this is the ray diagram in which the position of the object is taken at far distance. So at very far distance we are calling it infinity. So if the object is at infinity, where the image is formed, so position of the image will be where the image is formed, where the rays meet. The rays are meeting at F, so the image is formed at principal focus, at F principal focus. What is the nature of the image? Nature in what sense? Whether it is real or virtual. Real image we can say that if the rays are actually meeting. Okay, it doesn't appear to be meet, but it is actually meeting. So it is real image, and real image are always virtual. Real image is always inverted. So the nature will be inverted. Okay, so inverted image will be formed. So the nature of the image is real and inverted. What is the size of the image? You can see that this much big object, after reflection, all the rays are meeting at that point. So a point-like image is formed. So size of the object is highly diminished. Diminished means decreased. So any object, the size becomes point size, point-like object. Point-like image is formed. So the image is highly diminished. Okay, a point size of image is formed at point F. Next, second case, we take the object somewhat nearer the image. So for the second case, the object is placed beyond C. Okay, it is at somewhat far distance than center of curvature. So if the object is placed here, AB is our object, then we need to locate the image of this AB object. So for point A, we are taking some specific rays. Okay, so one ray, we are taking ray parallel to principal axis. So a ray parallel to principal axis will pass through F. Okay. And second ray we will choose a ray passing through C. Okay. So if the ray is passing through C, then it reflects in the same direction. So for the point A, where the image of point A will be formed. So a ray incident on the mirror, after reflection they are meeting at point this. Are you getting the idea? A ray passing through incident on mirror, after reflection they are meeting at this point. So at this point the image of A will be formed. So we are calling it A prime. Okay? Image of A is A prime. So similarly, for all the points of the object, we can locate the position. Okay. For B, the ray passing through the principal axis and coming in the same direction. So the image of the B will be here at B prime. And in between A and B, all the points will be A prime to B prime here. All the points image will be there. So it means that if the object is beyond C, then the image will be formed here. So what can we write about the image? Position of the object is beyond C. Position of the image. Where you are getting the image? Between C and I. So the position of the image will be between F and C, or also you can write between C, center of curvature, and focal point. Nature of the image. What you can see, the rays are actually meeting. So the nature of the image will be real, and you can see the image of A is downward. So you can say that real images are inverted. Okay? Inward image will be formed. And size of the image, you can clearly see that AB and image A prime B prime is somewhat smaller than the object. So size of the object, size of the image will be smaller than the object. So this is how, by changing the position in front of the mirror, the nature of the image will be different. Okay, so draw these two cases in your notebook and write down the details. And still, if you have any doubt, you can ask me. Thank you. Further, we will see the next 4 cases. Okay.